All right, good morning, good afternoon, good night, good everybody. So today I'm gonna solve problems called number of islands 2. So since this week I'm trying to learn union find, I'm gonna focus on those most of the time. And let's just get started with this problem. So we're given a 2D array binary grid. So speaking of binary, is gonna be 0 and 1 with a size of n times n. The grid represents a map where 0 represents water, 1 represents land. Initially, on the cell of the grid are waters, and we perform land operation, which turn water into land. And I am giving an array of position, which is we have row and column, which would have an operator I. So return an array of answer, and we count the island after we returning the cell. Okay. An island is surrounded by waters and form connection adjacent land horizontally and vertically. You may assume 4 edge of the grid and all surrounded by water. Right. So let's say we have an array of position right here. It's have 0, 1, 2, 1, and 1, 2, and 2, 1, right? So 0, 0, this one is gonna turn to like an illustrator. This one gonna turn to land, and then the next, and in at this point, at this time, we only have one island, right? So we put that in our result, and then the operation continue with the position index 1 right here, 0, 1. So the operation turn this cell into a land. So right here we have two land connected with each other, and it's form one island, right? So this is one island also, and then we move on 1 and 2 right here. It's turned this to a land. So we have two island right here because we only count up, left, right, and down. So this is not counting diagonal. So we basically have two island, right? And then things go on till we have a bunch of islands. So the naive way to think about it is we generate a whole grid, right? Just like this first grid right here. And then for each operation, so for each temp, maybe we have a for loop right here for each position, right? For each position and position, right? Each time we're doing that, we convert this cell into this cell, and then we pass this into a BFS function to count, right? BFS function return count island. I think this one is the count islands. This one is from the number of island 1. So this part only is that part, but it's gonna cost a lot. So BFS or DFS, the time complexity is for this problem is gonna be m times n. And what if the position is a whole lot, right? So m times n, it would be m times n plus this position. The worst case of the position operation is also gonna be m times n because there's that amount of cell on it. So it would be m times n square. So basically, it's not a really good operation. So we need to find something else. And union find comment. So union find every single cell in here. We define every single cell in here is it's a possibility to become an island, right? So in the beginning, every cell, let's say I have cell 0 right here. Let's try to make this grid a little bit smaller. Let's do it this way. We have this cell, right? So we only have this 2 by 2 square, which is on 0, right? So in union find, the index of this shell is basically one node in the union find tree. So right here, hopefully this makes sense. And the parent, and they are a parent of itself. So let's draw it like this, right? They are a parent of themselves. Let's say we are, okay, let's say we need to go through all of the position right here. We have 1, 1. We have 0. This one, we operate it. We turn this to 1. Oh, oops, what am I doing? Oops. Right. This is a 1 now, meaning that, oh, we have one island, so the count of it is going to be 1. Right? It's going to plus 1, plus is equal 1. Right now the count is 1. So in here we have to check that is there any other island is also next to it, this one island, this one, or this, is there any islands of it. So we will scan, let's say we scan the right of it, up, down. This one is out of bounds, this one is water, this one is also water. So when we scan, we need a visit, we need a visit set. So if we, let's say we have this operation 1 right here, we add that to the visit. So this one is 0 and 0, right? So let's say if we found their neighbors right here, like this dot right here is in visit, it means that it's the land, right? So since if it's a land, we will have to union the land, but we will look at that on the next operation. So since visit is not here and nothing to do here, so we move on to the next position. Let's say 0 and 1, right? So we have 0, 1 right here. And then we count it 2 because we have 2 island, right? We have 2 island. In the 2 island right here, just remove this, put 1 in here, 2 island. So we do the same operation. We search up, down, left, right. Oh, we found another one because it's in visit, right? So at that time, we're gonna do union. So when we do union, right, the union will basically find the parents of itself. So in here we have 0, 1. We find a parent of, they are different parents right now. So when we found this 2, it's not a parent, we start to union it. We just link it like that. And then this one is no longer a parent of itself. This one is the parent. And then we decrement the count. So right now it's only 1 island. So basically that is how the algorithm works. Let's say if we even have this one right here, just arbitrarily this one right here, we go in here, we search, and then there's nothing around it. So this will be, the count would be 2 right here. So that's make a little bit sense, right? So hopefully my explanation helps you understand what is this about and why union find come in to play. So just let's code it up. All right, so now let's get started. Firstly, we're gonna have the direction array right here. It's gonna be simple. Let's see if I remember that. 0, 1, right? Oops, what am I doing here? 1, 0, and then 0, -1. Right, I have a row column equal to mn. I have the visit, which is equal to the set. I also have a union, which I'm gonna do it later because why not? Right. The union will be initialized to m times n. So this is what I'm gonna explain. Result would be equal to an empty array, so I can return it, and then we have my count initialized also. So right now, let's go through each position. So I have row and column in positions right here. So if that position is already in visit, right? If that already in visit, just in case that the queries in the position repeat itself, that is one edge case, we're gonna just append that count into our result and then return it and increment the count. Oh, my bad, not increment the count, just continue here. So now we can add to the visit set our array, no, not array, our tube, and then we increment our count, meaning that, oh, we just add 1 more land for the index right here. So I will have 1 index value right here. I'm gonna explain why I am using it. So this index is gonna be row, current row times big column plus column right here. So this one is meaning to flat the 2D array into 1D array. So meaning that if I add into the union find class, right, I want to, instead of adding tube of 0, 0 or tube of 1, 0, I want to convert these numbers into some kind of hash, so it will be a little bit faster using that. But you can also do a two row and column and using a hash map. That's just also fine, but I'm gonna use this one. So for direction, row, direction, column, in direction, right, row, column, go to the row, direction, row, column plus direction, column. And then we also have the new index, right? So new index equals to new row multiple with the columns, and then plus the new column. So in here we need to check the outbound. So if min of the row and the column smaller than 0, we continue. If the row and column outbound the other way, so right here, or on column, go to column, this outbound on the other side. And also if this part is very important, so if row and new column is not in visit, so this means since this one is not in visit, it means that we haven't put land on that thing, but we haven't convert that into land. That is just water, so we're not gonna do anything on water because we only do union find on the land, right? So we continue this, but usually you see the DFS start with in visit, but in this case the opposite. So continue if union did it right. If union dot union, I'm gonna union these two index. So index here, index there, right? Count. So if I union something, I'm gonna decrement the count, right? And then in here I just append my result into the account, into my result, and I just return my result right here, just like that. Now I'm gonna start implement the union class. So union, in here we gonna have our init function self. We will have a row. We will have n and n, right? Let's just call it, in general is n. Let's say general is n, right? So self dot the parent is not gonna be, usually we do hash map, but we're not gonna use it. We're gonna do an array of I or I in range n, right? So we create an array. Let's say we have 3 by 3 matrix. This array is gonna be 9 to store exactly 9 values in there, and each value is gonna be represent the coordinates of that thing, coordinates of the matrix. So let's do self dot rank. So it's just to use for a union. Okay, let's do define function find. Right here is node, right? Parent is gonna be self dot parent node, while parent go to self dot parent dot parent. So would be parent dot, my bad, it should be like this. So right now I'm just typing out the union find template, which just basically everyone's gonna use that same thing. And then I return p, right? In here I have a union function. I have parent 2 equal to self dot parent of node 1, node 2. If the two parents, if they are the same parents, meaning that they are on the same island, we return false. My bad. In here, if it's returned false, we did not like decrement the count. We just append the count like that. In here, I have a self dot rank p1, self dot rank p2, right? Self dot 1 is smaller. We're gonna put the parents of p1, which is gonna be p2, and then the opposite. And in the other case, we have parent. We arbitrarily just do that. Go to p2, and then we increment the rank of p2 plus equal 1, right? And then we return just like that. Yep. Let's try to run it, see if it's work. Looks like it's work. Oh, there's something wrong. Let's debug it. All right, I found my error. In here I say self parent of n2, right? It should be fine. I don't know. And it's really hard to debug because code still run The code still run since this function is doing well. So it's assigned the parent of itself. So that error can happen. But in here we need to use find to find the actual parent. Let's run again. And it should be good. So let's talk about time complexity for the position, right? It's, let's say the position is the time complexity of position is gonna be p, because p is the length of the position, right, plus the direction in here. So 4p. We do union. This, in the worst case, the position right here is cost, I don't know, it's maybe even more than m times n, because I know that we only have a grid and the operation which is only in this grid. So this 4p is just m times n, whole grid 4 times m times n. Union find function is cost, it should cost log n, because it should have cost log n, but since we add these and the ranking system, the log n in here is somewhat of 1 because of our inversive Ackermann function. So in general, it should be only m times n, and the space is also gonna be m times n, just like that. And thank you so much for watching, and see you soon on the next video.